Okay, today we will be doing numerical problems on gravitation. Page number 361, question number 5, which is your question you are asking me, so I am doing it. Question says the mass of the earth is 81 times that of the moon, while its radius is 4 times as large as that of the moon. Compute the value of G on the moon. Okay, the value of G on the surface of the earth is given 9.8. So we know the formula G is equal to actual formula goes like G M by R square. G equal to G M by R square. So this one I take for the earth. First you can add ME, here you can add RE. Mass of the earth, radius of the earth. G dash on the surface of the moon, I write as G M and I write as M moon. Radius of the moon square. Equation 1, equation 2. So we will divide. Let us divide that G by G. Anyone you can divide G by G dash. When you divide, this will cancel. You can add here ME by M. Radius wise, it will be just opposite. RM squared by RE squared. Radius of the moon, radius of the earth. Just to differentiate from one another, I am using the subscript E and M. I'll put the value. They're saying mass of the earth is 81 times the mass of the moon. That means this is 81 by 1. Ratio will come this. Now radius of the earth is 4 times the radius of the moon. Question says. That means this one is 4, then this is 1 unit. Radius of the earth is more. So radius of the moon is 1 unit, then radius of the earth is 4 units. Let us calculate the answer now. This will come G upon G dash is equal to 81 by 16. Therefore, G dash value will be coming 16 by 81 times of G. You can calculate the value of G dash is equal to 16 by 81 into G value is 9.8. You can get the answer. You can calculate. Calculate and tell me what is the answer. What answer do you get? I'm sure you get the answer 1.94. This
Yes,
will
sir.
come 1.94 meter per second square. This answer. First answer comes. This is answer for part A. Now part B. We'll do part B now. What will be weight of the body of moon if it weighs 10 kg weight on the earth? 10 kg weight on the earth. Okay. Weight is given 10 kg or 10 kg weight. We'll find mass. On the surface of the earth, I'll write formula. Weight means you can add mg value is given 10. 10 kg weight. 10 kg weight. Therefore, m value will be 10 kg. Mass will be 10 kg. Now, therefore, that weight on the moon. Weight on the moon will be equal to mg dash 10 into 1.94. The answer is coming
19.4.
19.4 Newton. We can add 19.4 Newton. 19.4 Newton. In Newton only you can give the answer. You can give the answer in terms of Newton. Okay? Alright. Now,
So kg weight and Newton is same.
no, 1 kg weight is equal to 10 Newton or 9.8 Newton. 9.8 Newton.
So you didn't divide out, mg is equals to 10 kg weight. Then m will be 1.
No.
Therefore,
Here. G,
yes, sir.
G value is how much? 9.8, no? Here also to multiply by 9.8. 9.8 will cancel. You get mass value will come in 10 kg. If you want to change this answer into kg weight, no, you have to divide by the value of g. And what is the value of g? What is the value of g? Or the value of g is, that is 9.8. You divide by 9.8, you get that answer. 1 kg weight equal to 9.8 Newton. If you change this into kg weight, you can divide by 9.8. Divide this answer by 9.8, check the answer.
1.98.
That answer will come. If you have to change, otherwise you may not change. You can keep it like that only. You can add 19.4 divided by 9.8. The answer will come kg weight as given in the book. We have the relation like this. Okay, follow this. 1 kg weight is equal to 9.8 Newton. Okay. In 1 kg weight, the mass will be 1 kg. In 2 kg weight, mass is 2 kg. In 40 kg weight, mass is 40 kg. So same way, 10 kg weight, what is the value of mass? 10 kg. And after that,
Yes,
I will
sir.
wait. Okay. Now which number? Any other number in between, you can ask me that also. Otherwise, I will go to next number which you are asking me.
Sorry.
7.
Huh?
7.
No. Between 5 to 9, do you have any number to ask? Did you do number 7?
Sorry, 8.
So 7.
Okay. Have you done number 7?
No,
No, sir.
Okay. Number 7 you should do. I'll do number 7. Question says, how far from the Earth's surface does the acceleration due to gravity becomes 1% of its value at the Earth's surface? How far, that means from the Earth's surface, acceleration due to gravity becomes 1% of that of the Earth's surface. That means you have to find the value of height. What is the formula? You know the formula g dash by g. With respect to height, the formula goes on like this: 1 plus h by r whole power minus 2. This is the formula. With altitude. G dash by g value, write 1 by 100. 1 upon 100. 1 by 100. And here you will be writing 1 plus h by r power minus 2. 1 by 100, we can add 10 to the power of minus 2 is equal to 1 plus h by r minus 2. This will go. You get 10 is equal to 1 plus h by r. 10 minus 1 will become 9. 9 is equal to h by r. Therefore, h value will be equal to 9r. 9 times of the radius of the Earth. Then 9 and radius of the Earth is given in the question. How much is the radius of the Earth given in the question? 6.4. 6.4 into 10 to the power of 6 meters. Let us multiply it, the answer will come. The answer will come 5.76 into 10 to the power of 7. You can verify this answer.
So why
If
you took
you
1 by
take
100? This side.
1%, no, 1 out of 100. 1% is what? 1 out of 100. Let the original value was 100%. Now the new value is becoming 1%, the 1 by 100.
Okay, sir.
Okay? Done. That means at a height, this much height, the value of g will become 1%. But question doesn't ask you how far from the surface of the Earth. Question says that it can be above the surface of the Earth, even it can be below the surface of the Earth. Now we will find below also. Both answers you have to find. This one is with above. You can add on top above the surface of the Earth. Above the surface of the Earth. Second case, below the surface of the Earth. Below the surface of the Earth. Second, that time the formula will be g dash by g is equal to 1 minus h by r. This is the formula. With less equal to 1 minus this coming 1 minus 1 by 100 h by 100. Therefore, H value will become 90 into, that is 9900 into R. Now I put this will be the second below the body is taken to from the value of G of 1%. But you should that means it can be below. That's why I'm finding both. Done. It
We
is
have to write
completed.
that one also below the surface of the earth.
Yes. So both. Now which one? Number 8.
Sir, wait,
Somebody
sir,
was
don't
asking
rub
number
that
8.
one. Sir, don't rub
Okay,
that one.
below one
Right side.
Okay. Now I'm doing number 8. Doing number 8 now. Okay, ready? Yes, Upamanyu.
Yes, sir.
Ready? Okay. Question number 8. A body is projected vertically upward with a velocity root gr, where r is radius of the earth. To what height the body will rise? So this one is based on formula. What is the formula of maximum height reached by a projectile? You can turn over the pages and see and tell me what is the formula.
Sir, u square by
V
2g
square
into
by
sin theta.
R.
Sin square theta.
Write that formula, right? H is equal to V square R by 2GR minus V square. Isn't it? Please
Yes,
check
sir.
the formula. If there is a mistake, you remind me, then I'll correct. Okay, now
Correct.
H is equal to V value I'll put now. V value is root GR. When you square it, it becomes GR. When V square value, you can put GR into R, like 2GR minus GR. You can write since V is equal to root GR, therefore V square value is becoming GR. So 2GR minus GR subtract that GR into R, this is coming GR, GR will go, therefore H is equal to R. That means when the body goes to a height equal to R, that time the velocity will be equal to root GR. This is the answer. If they give the value of R in kilometer and also the height value will also be the same. This is the answer. This is at this height, at the height equal to the radius of the earth above the surface, the body will go. Okay. Now some of you are asking me number 9, huh? Number 9 was there no in the list. Some of you are asking number 9, no? Say no, don't be just quiet. Say.
Yes, sir.
I think number 9 is same only. Formula, just formula we use, same formula. Formula is same.
Yes, sir. Now we
A
can do.
projectile is fired vertically from the Earth's surface with a velocity of 10 kilometers per second. How far it goes above the Earth's surface? Radius is given, G is given. I think you can do it.
Yes,
Velocity
sir.
is given 10 kilometers per second. While calculating, you must change this into meter per second. 10 kilometers will be 10,000. The value of V will put 10,000. Okay. And radius R value, you will put 6.4 into 10 to the power of 6 in meter only, whatever is given. And the value of G, you will put 9.8. And you only have to do the calculation. I think it is directly formula based and use of calculator. Okay, it will be done then. Huh? I don't see any problem here in this question.
Yes, sir. 9 we can do.
Okay, 9 you can do. Then tell me, check and tell me which one you find slightly difficult to ask me, then ask and I'll do it. At least I'll give you a hint. Number 11 you can see. Just read number 11. Read number 11. Have you read number 11? If a body is to be projected vertically upwards from the Earth's surface to reach a height equal to 10 times the radius of the Earth, how much velocity should it be given? R is given and G is given. Can you do it? Same formula. Height reached by the projectile is 10 times the radius. You can H value you can put next time 10R. 10R is equal to this value. And after that, I think you can calculate V square, no?
Yes, sir.
And V also you can calculate. RR will cancel and you can do it. That is the hint for number 11. We'll try at home. Okay, once. Now, question number 12. Number 12, have you done or have you tried yourself? Number 12. If not, then
Tried,
I'll give a hint.
difficult. So hint.
Difficult. Okay. Number 12, I have already done in the class only. I have done it in the class. And you did not notice it. Please go through motion of satellite. Go through it. Turn over the pages and see motion of satellite. Have you turned the pages? Please turn over the pages. Theory part. Motion of satellite is the heading turned. Okay, go through there. Orbital velocity formula, what was it? Root GR, no, square root of GR for satellite close to the surface of the Earth. Close to the surface of the Earth. Can you see that part?
Yes, sir.
And after that, what formula? How did I change to omega 2 pi by T and all those time period? Time period formula now becomes 2 pi square root R by G, capital R divided by G. Do you see that? And I wrote the answer there also. How much answer did I write there? Just check.
846 minutes.
84.6 minutes. Is answer same
Yes.
here given in the book? Just see it. Then what you want to ask now? It is done now. You are not
Yes, sir.
understanding theory part here. Theory part is you should understand. Huh? But anyway, exam time, if suppose you don't know the idea, what to do, I'll just give an idea. Huh? For satellites and planets revolving around, no, then centripetal force is equal to gravitation force, will equate. So what we will do for that, I'll write that is mg squared by r is equal to gravitational force g mm by r squared. M and then we can cancel. RR also will go. V square value will come Gm by R. Okay. Now here V square Gm value we can add Gr squared by R. If question asks you find velocity, this V is the velocity you can find by using this equation. Now the satellite is very close. When the satellite is very close, this small r and capital R will be equal. The capital R is and R square cancelled, answer will become only Gr. But it is only for close satellite. But if they are saying satellite is at a height of some meter, maybe 100 kilometer and all above the surface of the Earth, then R will be equal to capital R plus H. Just now satellite is very close. I can just go like this. Gr squared by r are cancelled. V square value is g into r, and this will give the value of velocity. In the question they're asking to find velocity also, and the value will come. G value is given in the question 9.8. R is the radius. Radius is also given in the question. Use that value and calculate the value of V. Your answer will come just now in meter per second, which you can change in kilometer per second by dividing it by 1000, and you will get the answer. But if they ask you to find time period or period of revolution, we can continue further. V is equal to omega r, we like have omega squared. Small and capital R is equal, so I like capital R squared is equal to G R. R and R will go, so omega squared value is coming G upon R. 2 pi by T whole square is coming G divided by R. 4 pi squared by or square we can remove and put here root. 2 pi by T is equal to root Gr, therefore T value will come 2 pi cross multiply R divided by G. This is the value. This is the value for very close satellite. And R value you can put radius of the earth given in the question. G value also you can put. Calculate the value of time. This value of time will come in seconds. Answer will come quite big, 5,000 something will come, which you can change into minutes. Dividing it by 60, you will get the answer in terms of minutes. And if there is a need, you can change in hours and also there, like 1 hour or 1.4 hours, 41 hours will come. So this is done. Now, which number? The technique of satellites and planets doing is this one. Centripetal force is equal to gravitation force. We will equate. And just cancel and all and then proceed. If the satellite is very close, then small r and capital R will be equal. But when the satellite is not close, then r, small r value I like as capital R plus h. I will be adding the total distance. That means radius of the earth plus the height given in the question. That I will add and I'll put the value and then I'll calculate the value of V. The answer will come something different. Okay. Now which number?
So 15 to int. 15b.
Okay, 15.2. All right. Then rest of the question is same as this one, huh? Number 15. I'll do number 15, or I'll rather give the hint, whatever you want. Okay. The question here is, the mass of Earth is 81 times that of the Moon, and the radius of the Earth is 4 times that of the Moon. If the acceleration due to gravity of the surface of the Moon is 9.8, find its value on the surface of the Moon. I think you know the answer.
Yes, sir.
First part we can do no. First part we can do as I did before. The answer will come 1.94. Same as question number 5. Somebody asked me to just know only today. So this first answer is same as the previous one, 1.94. Yes. Yes or no?
Sir.
Okay. Second question, if the escape velocity from the surface of the Earth is 11.3 kilometer per second, what is the escape velocity from the surface of the Moon? We have to find the escape velocity on the surface of the Moon. Okay. So for this question, second part I am doing now. First part is already done. Second part B, that is for the part B, escape velocity on the surface of the Earth formula will be root G into R. Right here for Earth's surface. Escape velocity on the Moon, that will be G dash into R. Here I let R E and here I let R N. And here I let V and here I let V dash. Okay, I'll divide the two of them. Let us divide. You get VE by VE dash. Here when you divide, your answer will become G upon G dash into RE by RN. Now I'll put the value. Escape velocity of surface of the Earth is given 11.3. So that 11.3 kilometer per second, keep in kilometer per second only. G by G dash, G value you got 9.8 given and G dash is you found 1.94. RE, radius of the Earth and radius of the Moon. They are saying ratio, I know the Earth radius
4 by 1.
4 times 4 by 1, very good, 4 by 1. Now get the answer. Calculate. Calculate.
Yes, sir.
Calculate, you will get the answer coming. VE dash, as per the answer in the book given, I will write 2.51. 2.51, same unit. Kilometer per second. Kilometer per second. 2.51. That's the answer. Okay?
Yes, sir.
Okay, take one question. It is not in the book, but it is my own question, just write. Right. Find the speed of rotation. Find the speed of rotation. Find the speed of rotation and the duration of a day. Find the speed of rotation and the duration of a day when a body at equator, when a body at the equator, when a body at the equator is found to be wetless, when a body at equator is found, F-O-U-L-D, found to be wetless, found to be wetless, found to be wetless. Okay, that is the question. So how to do? How will you do it? You have to find the speed of rotation of the Earth, or with what speed the Earth should rotate, so that the object or a body at equator becomes weightless. So we will be using the formula of G at equator, where that at equator, the formula of G dash goes like this: G minus omega square R. This is the formula. If you don't know, please look at the formula. G dash is equal to G minus omega square R cos square lambda. Actual formula is cos square lambda with respect to the position of the Earth. And lambda value is 0 degree for the surface of the Earth. For the equator, the value of lambda is 0 degree. The cos 0 degree is 1 and 1 square remains 1 only, so the answer becomes this. But according to this question, the body becomes weightless, that means G dash value becomes 0. Mass cannot be 0, but the acceleration due to gravity is becoming 0. So write that G minus omega square R, this will come this side, omega square R is G, therefore omega value will come root of G divided by R. G value you can put 9.8 and R value is 6400 kilometers, that is 6400 into 10 to the power of 3. This will calculate and get right answer radian per second. Radian per second. Now, after finding omega, then you can find time period. Omega value can continue that 2 pi by t is equal to root G by R. Therefore, time period value will come 2 pi square root of R by G. Now, here also you are putting the values. R value you are putting now 6400 into 10 to the power minus 3. And this is 9.8. I'm sure your answer will come 84.6 minutes. We have done it before also. Or 1 hour, 1.41 hours, 1.41 hours. Or we can say 1 hour and 14.6 minutes, 24.6 minutes. 1 hour, 24.6 minutes. We can say that. Okay? Yes. All right, boys. So this chapter is over. Next class we will start a new chapter, fluid in motion. Fluid in motion. Okay, we will start that in the next class. Okay, fluid in motion. We will do that next day. I mean tomorrow. Then thank you. This chapter is over. Done. All right, I'll close.
Thank you, sir.
Yes, sir.